Yeah, we're live.
Alive, yeah.
Yeah, perfect. Okay. So just briefly introducing the landscape in which Kedro was built and talking about the common challenges that a lot of data practitioners face, and where Kedro was basically finding a solution for. So what we found was that within the organization of QuantumBlack, that we tended to under-engineer data science experiments and create code with a lot of technical debt. Where technical debt is, of course, this thing that you accrue over time. It can be intentional, it can be accidental, but usually they make your code more difficult to understand, makes it harder to maintain, and then in the end, it also makes it harder to add new features. So it's really kind of like even a regular loan, you have to pay it back at some point. And usually the way that technical debt is paid off is that the people building the models, usually a data scientist, they hand over the code to data engineers or machine learning engineers, so the people who need to productionize whatever experiment they've been working on. And I don't know about you, but I think it's a great job to be cleaning up code from someone else and paying off that technical debt. So it also leads to friction sometimes, and it's not the best way to basically just create a notebook and then rely on someone else to make sure that that can be run in production and actually run on real data. What happens a lot as well is, well, the technical debt is one side, but very often when people work on machine learning products, they may be used to a notebook flow. But when they then have to work with teams and deploy things, they bump into all sorts of things. And these quotes are all from users, Kedro users, and people that were maybe our target audience. And they told us things like, when I work on machine learning, everyone always works in a different way. We have to establish best practices and how we work. But also as a data scientist, people often felt that there's so many things to learn about, like all these tools to create high quality code. Then when I dive into it, I need to know about Sphinx for documentation, Flake 8, isort, Black, all these things for linting. I need to know about Docker, virtual environments, PyTest. It's just so much. And really, honestly, like, it's also not really fair to expect data scientists to also be great software engineers. And the best way to kind of deal with all these issues is actually to embed best practices. And in traditional software, best practices or best software engineering practices would be seen as a process or approach that is understood to help build software that's superior in terms of speed of execution, shipping with higher quality, or building more maintainable code. So in a nutshell, embedding best practices into your way of working and into the machine learning projects you build will help you build more robust projects that hopefully don't accrue as much technical debt, but also manage it in a better way. And in the end, you don't have to just throw a notebook at your colleague to clean it up, but you can work together to actually build something that's more maintainable and robust. And that's actually where Kedro also enters the picture, because while we were at QuantumBlack, while our colleagues were making machine learning projects, they found that they were doing similar stuff over again, were accruing technical debt along the way, and weren't always working the best way. And so we built Kedro in-house way back in 2017. But nowadays, it's an open source Python toolbox that applies software engineering principles to data science code, making it easier to transition from a data science prototype and an experiment to something that you can run in production at large scale on real data. So very briefly, the project itself was built in-house at QuantumBlack, but nowadays it's part of the Linux Foundation, and it's adopted across lots of big enterprises, sometimes through collaboration with our own team, but also many times because people just found it useful themselves. And we also have a technical steering committee. So the project isn't only maintained by me and my team, but also by people from other companies who see the benefit of Kedro. Yeah, and so in kind of our tagline is that, we built Kedro to reduce technical debt in data science experiments, making an easier transition from experimentation to production, and really helping you while you're building your data science code to embed best practices. So it's not a matter of having to rewrite stuff, but really along the way, make sure that the quality of what you write is actually high enough to run in your production environment. And Kedro does it through the features that it has. So every feature that we added has a best practice kind of nested behind it. And that's also what I'm going to talk you through in this workshop today. But I'll highlight a couple of them. And there's actually three that we'll be playing around with in the workshop. But the first thing that Kedro kind of gives you is the project template. And this is a way of embedding stability and consistency into your projects, making sure that every time you start a new machine learning project, you use the same format. Then there's the data catalog, and it's an abstraction layer on input and output, making sure you have consistency in the way you deal with data, but at the same time also separating your data logic from your modeling logic. Then there's nodes and pipelines, and these are really the building blocks of a Kedro project, and they make sure you can create a data-centric workflow, write your code in a modular way, and also assemble it in a logical sense. And then we have features that are a little bit more on what I would say the road to production a bit more. So there's experiment tracking, which you can use to, of course, make sure that the model that you're developing is still performing at the level that you want it to be. And then extensibility, which is really what where deployment comes in. So if you do want to deploy it somewhere, Kedro is very easy to extend to whatever environment you have. All right, so that's it for the introduction. Let me just quickly see, are there any questions at this point? I don't know how to switch without...
Yeah, there aren't any questions in the chat now, but yeah, we can give it maybe a few seconds just in case anybody does want to put anything in the chat. Yeah, we're just saying thank you for the introduction.
Perfect. Okay, then let's...
I guess it's also up to you whether we continue the recording at this point. I'm happy to continue if you want, but...
Yeah, definitely. Go for it. Right. Yeah, so let's dive into some of the best practices. And this is where I'll introduce a best practice, and then we'll go into the hands-on part of this workshop. So the first best practice I want to talk about is modularity. And in the world of software, modularity is essentially a term that explains breaking down a complex system into smaller independent modules. And for each of these modules, it's important that it's responsible for a very specific function or a feature, and it can operate independently of the other modules. This also means that your modules should be loosely coupled, so they shouldn't depend on each other too much, because then you can also reuse them in other components of your system. Having your code structured in a modular way will also make it easier to read your code, because instead of having a notebook with 1,000 lines, you would have separate functions, which in turn it also makes it easier to collaborate, because it will be easier to navigate the code, find different parts. And then each of these components will also be easier to test, because instead of having to test 1,000 lines, you would have smaller chunks. And of course, if you can write tests for something, it will also be easier and faster to find bugs in case something goes wrong. So in the world of Kedro, the way we've introduced modularity is through nodes and pipelines. And the concept of a node is actually nothing very revolutionary. It's just a Python function. But mind you, it has to be a pure Python function, which means that it has input and output, but it never modifies the input or the output. So it will help you to always think about your data flow, in the sense that you would input your data, do some like pre-processing, for example, and output that data, but never modify your raw data. So in case something goes wrong, you still have your intact raw data along the way. Node definitions in Kedro can also have multiple inputs for things like, joining different tables. You might want to put 2 tables in it, merge it, and then create, for example, a training and test data set. And then nodes together essentially create a pipeline. So a pipeline is a collection of nodes where the relationships between the nodes are defined in a way that the input and the output are connected. So for example, if I have node A that takes in the raw data, does some pre-processing, and then stores that as an output, and then I can have node B that consumes that processed data, creates like a model input table out of that, and then again passes it on to another node that maybe takes in the data to then train the model on it. And in Kedro, a pipeline is always a directed acyclic graph, which means that you have basically a clean flow of data. There's never loops going back. And the reason why is to make things very separate. So each module has its own responsibility, and it's very easy to test each of these modules because there's no unexpected loops in there, and you will be able to test them easily. So modularity at its purest in the world of software is making sure that your system is divided into separate components. And in the world of Kedro, we make it easy to do that through nodes and pipelines. And that's exactly the first thing we're going to be doing in this workshop. So I have prepared an example project for you, and the final piece of code looks like this. So this is a visualization created by Kedro Viz that demonstrates the pipeline that we're going to be building. And the project that we're building is essentially a data pipeline to predict the price of a trip to space. And the data that we have available to us is shuttle data, and shuttles are essentially the space shuttles going through space. We have data about the companies that provide space flights, and then we have customer reviews that basically say what the space flight was like and how much it cost, et cetera, et cetera. And what we're going to be doing is we're going to pre-process some of that data. Then we're going to create a model input table. We'll create a split, or we split the data into training and testing data. Then we will train the model with that, and then eventually we'll evaluate our module. So hopefully this looks like a fairly standard data science pipeline to you. And this is where I'm going to be switching to our working environment. So by this time, I hope that most of you have been able to at least try spin up Git pod, or otherwise clone the repo. In case anyone joined late and doesn't have the links, do shout now so we can share them again with you. Because this is basically the point where we'll start doing some more hands-on coding. I'll go slowly. If you have questions or if I'm going too fast, please do interrupt. But otherwise, code along, work along with me, and we'll transform basically the code that I've provided to you into, again, where's my slide? There we go, into this beautiful pipeline that we have here. All right, so once you've checked out the repo, or you spit up the Gitpod environment, we'll have, it's basically an online IDE. It's VS Code. So if you're used to using VS Code, this should feel familiar. But what we're going to do is navigate to the notebook tab, where I've created a Jupyter notebook with a representation of this space project. But I've basically done everything that I've just said is maybe not the best way of working, because I created just one notebook with the code in there. I did divide it into cells, but otherwise this is literally just lines of code. And imagine, like, we need to imagine that this is my experiment, but ideally I do want to put this in production. So we're going to transform this into something that embeds these software engineering best practices, and eventually transform it completely into a Kedro pipeline, so it's ready for deployment into our live systems. But in order to actually try and experiment with some stuff, I want you to also try and run the codes. So if you're new to Gitbot, to execute a cell, there's this play button here. And the first time you do it, it will ask you to select a kernel. So just for like a regular Jupyter notebook. And to make it easy, they already have a Python environment set up for you. So I'm just going to go for the recommended environment. And I think, yeah, it's telling me all these things that you can ignore. But that's essentially good news. So it means I can now run these cells. And while I run them, I'll explain what's happening here. So in the first line, in the first cell, I'm just importing pandas and I'm reading some data. And you might be like, okay, great, where's this data coming from? I also added the data into this project. So it's in data and then exactly these locations: raw, company CSV, reviews, shuttles. So you can play around with that as well. And now since we've loaded the data, I can do things like inspect the first 5 rows and just treat them like any pandas data frame. This next part is where I'm actually going to be pre-processing the data. And if we just have a look quickly again at the graph. So what I've essentially done, I've just read in these 3 first data sets, my shuttles, companies, and reviews. And now I want to pre-process my shuttles and companies. So that's what's happening in this first bit. It doesn't really matter what I'm doing, but essentially it's just cleaning some of the columns in the data sets and then saving it back to my original data frame. So if I just run this, it won't put out anything, but you can, of course, if you want. Oh, can I put this up? No. Okay. You can, of course, just check out the companies again, and now you should see a difference where the IATA approved went from FF and T to true. Yeah, I don't even know if that's correct, but that's fine. It's about the fact that we've modified the data. Now, the next thing we're going to do is actually create a model input table. And what happens here now is we take the pre-processed shuttles and we merge reviews with it. And then finally here, we actually merge companies to it as well. And then we'll end up with a model input table. Then in this cell, this is where we actually are going to be creating our training and test data based on the features that we want to inspect and this model input table. And we'll end up with our training and test targets. And then in the last cell, we'll actually train the model, which is just a basic linear regression thing. Nothing fancy, comes straight away from sklearn. We'll fit the regressor with our training data, and then we'll evaluate it with our test data. And then the final thing is just we return our score. So if I run this final cell, we end up with this number. But this is just the explanation of the code. Now what we want to do is actually make it modular. And the first step to make something modular is actually just introducing functions. And that's exactly what we're going to do. I'll go fairly fast, but feel free to take your time. I will also be sharing some documentation at the end of the tutorial. So if you don't have time to code with me, you can always do it later. But essentially what I'm going to be doing is I'm just creating methods out of these things. So for this one, I'm going to just take loads data and just indent this all. And then at the end, return all of these data sets. This cell I don't need, so I'm going to delete that. I'm going to do the same for this one, pre-process data. But mind you, what I actually want to do is want to split these two, because then I can say this is pre-processing companies data. And then the other one will be pre-process shuttles data. And the reason why I'm splitting these is a little bit of preference, but I like the fact that these are now very separate entities, and I can, if I need to maybe pre-process shuttles for another pipeline, I can just call that method again, and I don't have it combined with the company's data. And that's really also the thinking behind modularity, wanting to make your entities as separate as possible and not mix responsibility within different functions. And so for these, I have actually pre-processed data, and the data that I want to pre-process is companies, so I do need some inputs. And now I'm going to return some output as well. What I could do is just, of course, return companies. But what I said earlier about pure functions is something I do want to try and keep. So instead of changing my original data, I do actually want to like change the name of this to make sure that I can actually eventually in Kedro save this as different data sets. I'm not gonna do all the steps in the notebook yet, but when we get to Kedro, I want to make sure that my code is as clean as possible, and I'm not modifying any of my raw data. All right, so I have a couple of methods now, but in order to call this, I actually want to create a main method, and I'll just call it my run pipeline, because what I'm essentially doing is creating a pipeline. And at the end, I'm just going to call it. And now I'm just going to be assembling all the methods that I want to call. So I'm going to start with load data. And load data is actually going to give me all the data I need. So I want to be using those outputs. And now I'm going to call pre-process companies data, which is going to give me pre-processed companies. Ooh. Mind the typos. And then similar for shuttles. Pre-processed shuttles. All right. So let me just try run these first two. And then does this compile okay? No. What did I do? Typo. Obviously, I didn't rename this properly.
I think it's not
yeah,
fine, because I think you might have to copy the data.
I need to sure. I'm going to be lazy right now and just do it like this, but I'll show you in Kedro how we do this properly. For the sake of time, I'm just renaming it here. All right, okay. That looks okay. How's it going for everyone in the call? Are you following me? Does this make sense? I see some thumbs ups. That's really great. Okay, let's move on, because I do want to get to the Kedro part, which is, of course, the interesting parts. So I'm going to be a bit quicker for this part. So now I'm going to create my model input table. Model input table. And this is where I'm going to be using the pre-processed data I create. So pre-processed company.
So we do just have one quick question in chat. Thing is the load data functioning an example of the node you introduced earlier in the talk?
Yes, but spoiler alert, this is not yet how we do it properly in Kedro. Yeah, should I spoil it now already? Well, essentially, in Kedro, we're going to be introducing another component that makes sure that you never have to even do this again. So stay tuned. Stay tuned. I'm going to show you. This is basically what I want to show you is how we got to even designing these parts in the framework. And how much easier it will be if you actually implement Kedro from the start. Because now we're doing a bit of manual labor, but hopefully it will become clear what Kedro can bring to you. Okay. One best practice I'm going to do as well is move all my imports up on my codes, not as part of my functions. Splits. Right.
Sorry, if I can just ask another question as well, because I'm just curious when you're talking about these pure functions of, I'm just wondering whether then you've got a bit of a memory overhead of, and maybe this is again going to be, how does Kedro deal with it? But if you've already got the data saved somewhere, is it so important that you're not modifying it?
Very good question. So my thinking for the main reason for me to use pure functions is for debugging, because if something goes wrong and you've modified your data somewhere, it's going to be very hard to find out where exactly that happens, because you've basically lost your raw input. So maybe you accidentally deleted a column, or when it was merged, some of the data was overwritten because there was a clash, and depending on the library, maybe it does a hard overwrite and you weren't aware. And I think especially, like, this, of course, is a very simple toy example, but what if you're working on a code base with 3 different people? Maybe not everyone's aware and you've accidentally changed stuff along the way. So that's essentially like my core reason for trying to not modify your data along the way, but instead returning intermediate snapshots of the data you've modified. Cool. And anyone who was watching me change this, I've also put my hard-coded values as default instead of inside the method, so it's easier to spot what's going on there.
Also, that is very impressive. Not only live coding, but you're multitasking, explaining, and live coding. This is very, very impressive.
I have done this before. I mean, I've written this code, regressor, but I'm sure there's going to be some compilation errors at the end of it. Regressor, and then finally, what am I putting in? And here I need this is going to be. Don't worry if you're not completely following along with me, by the way, because I have added some code for you already, so you can uncomment when we get to the Kedro part of things. But let me just explain what I did. So I essentially just changed everything into Python functions, where I have some inputs, and I realized I have to change some of these names. Go. Split and train data, train the model, evaluate the model. Okay, so now I'm gonna call everything in my main function. So this method here, and that's gonna
Sorry for interrupting, but I'm thinking we should have X test instead of test. I don't know.
probably, definitely. Thank you. There was already a typo happening. Yeah, and I'm actually a PyCharm user, so I usually have a lot of help on spelling, but I don't know how that works with VS Code. Oops. I mean, it's helping me a little bit, you see. And actually, for the ones who do use VS Code all the time, and if you are interested in starting to use Kedro, we have a plugin as well, which helps you while developing. I'll share some resources at the end. Okay, so I think I basically have.
You might want to be careful as well. I think there's a train model which is not quite spelled correctly.
Yeah, thank you. You're all helping me. I love it. Okay, I'm gonna try run all the cells, and then we'll spot any mistakes. Yeah, and then the final test. No. Preprocessed ED. Okay, well, you get the gist though. I've created modular components that I can now call and reuse whenever I want. However, this of course is still pure Python, and I want to show you what this means in the world of Kedro. For those of you who've maybe already explored the repository a little bit, you might have discovered there's some pipelines in there. But if we navigate to source, we have our placeholder pipeline folder, where we can find already established data science pipeline. And if you just collapse it and look into the nodes, you will recognize some of the code that we've just modularized, which is our split data, train model, evaluate model. And then in pipeline, well, I've commented out, but this is where we can do some easy uncommenting now. And then I'll explain to you. We've essentially created the data science part of our pipeline in a Kedro way. And I'll walk you through what we're actually seeing here. So a Kedro pipeline, as I mentioned before, is built up out of nodes. And a node is essentially a wrapper around the functions that we have created. So if I just split my screen and get the nodes on the side. So this split data here is referencing this split data function here. And it has all these inputs pointing to the inputs to my nodes, and the outputs are my the return statements essentially. And with this, Kedro has now created a pipeline which we can start trying to run. The only thing I must say, I'm not entirely sure if we can already get this to execute. No, I have to make some adjustment for that. Okay, but in order to do that, I realize I'm terribly running out of time, I think. Wait, how long do I have? I still have?
So I planned it until 8:30. So if you want, you've got up to 40 minutes left.
Oh, okay, that's actually not that bad. Then we're completely still in the...
Yeah, so I planned an extra half hour. There's a lot of workshop's going to be a bit,
good.
Yeah, a bit longer than a talk.
Thank you. Okay, well, in that case, we're going to take a step back and I'm going to walk you through exactly what's going on here. And we'll get to running in about 10 minutes. So I briefly already explained how these nodes are connected to these things here. But for the very observant of you, you have noticed that this part of the pipeline is only half of what we had in our notebook. So in order to assemble the proper pipeline, let's do that together. And let me just refer again to the graph so we all know what we're talking about. So we have basically made modules out of all of these things. And the thing that I built for you ready-made is everything from this kind of purple block. So where we split our data, and we have our training model node and the evaluate model node. So everything here with this little F for function are the nodes, and all the other things are data in between. So what we're going to be building is actually this top part, and we'll need 3 nodes for that. So we'll need the pre-process shuttles nodes, pre-process companies nodes, create model input table nodes, and then we have the top part of our pipeline ready. Okay, so let's go back. Oh, no, not there. Let's go back to our notebook. The part that we're now gonna use is essentially this top part. So loading the data, pre-processing the companies, pre-processing the shuttles, and creating our model input table. Now, Kedro has a very nice utility CLI where we can just create the pipeline setup out of the box by calling Kedro pipeline create. And all we need to do is come up with a name for it. So the second half of the pipeline I named data science because that's where we're training the model. The first part is a little bit more about preparing the data. So maybe we can call it data processing. It runs some stuff, and essentially what it does, it pre-populates your project with some placeholders. So it creates a folder setup for data processing, and it already adds a couple of files. So your init file, so Python can find the pipeline functions. There is a placeholder file for nodes, nothing in there, and a placeholder for a pipeline with the template on how to create a pipeline. I ran exactly the same thing for the data science, but then obviously already put a little bit of code in there. But now let's create this file ourselves. And I actually would like to start with nodes because that's the easy part. And I'm going to split the screen again because we did a lot of preparation while we were modularizing this notebook. So what I can do now is just copy paste the initial things I need. And I'm going to be a bit lazy and just copy all the imports to make sure I don't miss any. But I'll copy these as well. And then also create the model input table. Okay. Brilliant. So what we have now is just a file with Python functions. And that really is everything that nodes are. There's nothing special to this. There's nothing specifically Kedro about nodes. But what makes nodes special is that you can use them in a pipeline. So again, I will split the screen so we can work side by side. But what I want to do now is call each of these nodes inside of my pipeline. And in order to do that, we're going to need to just import it as well from the Kedro library. And now we can start using this wrapper. And the wrapper starts with just the word node. And then VS Code already helpfully tells me all the things that I can and I should call. So I need to put the function argument, inputs, outputs, and then what else? I can optionally add a name as well, and optionally some other things. But let's for now just start with function. I'm going to leave it empty for the time being. Inputs and outputs. Great. Okay, so these are the things I need to fill. So the first one of my functions is called load data. And this takes, of course, it actually doesn't take any input at the moment. So I'm just going to make that an empty string, but it does output a couple of things. So I'm going to need to add a list, and then it creates companies, it creates shuttles, and it creates reviews. And the reason why I'm putting this into strings is because that's how Kedro will interpret this later on. And again, a little bit of a spoiler alert. That's where our separation of concern around data loading comes in. But since that's a little bit more advanced, we're first just going to finish our notes. One thing that we also need to do is import our notes, actually. So do this from notes, import load data. And while we're at it, I'll do all of them. Okay. And let's create the other notes as well. I wish it was a little bit more helpful. Okay, yeah, there we go. Okay, for preprocessed companies data, I just need one input, which is companies. And my output is preprocessed companies. Okay. And then the next one. Oops. Shuttles. All right, and then this infographic is helpful and not helpful at the same time because it keeps floating in front of my stuff. Good. Okay, what were my inputs here again? Preprocessed companies. And this is where you shouldn't forget to add the quotes around it for strings. Preprocessed. Shuttles and reviews. Output is my inputs. Okay. How are you?
You need an ED at the end of preprocessed companies.
Thank you so much. And I also realized this one as well. Preprocessed. All right, how is everyone doing? Are you still following along? I saw some thumbs, yes. Great. Okay, so this is where I do want to go and start running some stuff. And I'm thinking perhaps instead of trying to run the whole thing, I'm first just going to verify that this pipeline works well. And a good thing is with Kedro, you can do that. We have this CLI command Kedro run, but you can specify which pipeline you want to run. And of course, this again is a small project, but if you have 10 pipelines, then you might have a lot of moments where you just want to run part of it. So I'm just going to be running the data processing.
That way you have a chance. There's a quick question in the chat, but I can let you run that if that's easier first.
I'll run it. Might break, so. Oh yeah, definitely. Broke. Inputs function expected.
Yeah, so it's just a question when you're ready for a Kedro with notebooks, which I remember you talking about other time. I guess specifically in this case with Databricks notebooks to enhance scalability, reproducibility, and collaboration while efficiently processing large data sets with Spark. It's the question if Kedro can help with that.
Perfect. Yeah, we do have an integration with Databricks specifically. So, well, the notebook part, I guess, is the easy part because what you can do is you can use Kedro as a library. So all of these components, like the pipelines, the nodes, you can just import them inside of Databricks notebooks directly as well. But we also have a plugin to help you do the deployment. So it can convert your projects to Databricks asset bundles and immediately deploy your Kedro project on Databricks as well. So there's many ways you can integrate with that. I think I still have renamed something. Preprocessed companies. Okay, what did I do wrong? There might be something wrong in my code. Let me just quickly check whether the other nodes are fine. Okay. I don't know if I just had a spelling mistake there. Yes, okay. We got through that one. Now the next one, I think the problem might be my paths. Yes, okay. So this is a little bit fiddly because we are in this this environment where, depending on if you're running it from the notebook or from the Python code, we need to adjust the path. And let me see, I think it might just be a matter of changing these. Not yet. Okay, you know what I'm going to do? I'm just going to use the full. This one there. I think they might have done it. Yes. And then we have another problem. This is the great stuff about live coding, right? Let me see what I did. I see it. I see it. I changed that name. Okay. Yay! We are live. We have a running pipeline. All right. How many of you were able to also run their pipeline? Anyone else, or am I going way too fast?
I think it's easier to watch you. At least I'm finding it very interesting to watch, but I think maybe it's a bit too fast to do it at the same time. But it is very interesting to watch the code. This is for me personally. I mean, I'm not sure how everyone else. Yeah, congrats on getting the pipeline running live.
Thank you all. That's very, very supportive. Let me explain what we're actually seeing here. So Kedro gives you a lot of logs about your process. Of course, this went fairly quickly, but it gives you information about what's happening. And specifically, it's telling us that when it's saving data, when it's loading data, and when it's completing certain things. So if we just start from the beginning, well, the beginning is basically confirming which project we are running, which is WCC workshop. It's giving us a little bit of information about data tracking. But then this is where actually it's starting to log our pipeline run. So it's telling us that it's running this specific nodes, that it's saving some of the data, that it's completed the first task. And a task here is actually, it's completed the first nodes. Then it's explaining that it's doing the second, et cetera, et cetera. So that's great. We have half of a running pipeline essentially. And this is also where we can experiment a little bit and try if we can get our Kedro Viz running, which is interesting to do from here. Yes. Okay. Wow. Okay. This actually runs straight out of the box. So this is the thing I was showing you in PowerPoint as well. But Kedro Viz is our visualization tool on top of the Kedro framework that shows exactly what we've been building. And the cool thing is you can do things like show the code, so you can actually inspect the code you've written. You can also check your data sets. You can see some statistics about it. So it's a very helpful tool while you're building your pipeline to check what's going on. So we have a pipeline, we can visualize it, but as we saw before, we can only run the first part, because if I try and run the full pipeline, it will complain about some things. And instead of just fixing this, I want to introduce another best practice, which is separation of concerns. To a certain extent, separation of concerns is connected to modularity, but essentially the thought behind this is that different parts of a software system should be designed to address different concerns. So it shouldn't just be split into modules that have an independent function, but specific roles should be dealt with different parts of the system. So for example, if you have any user interaction inside of your software system, that should ideally be a separate component. When you're dealing with data, any data access should also be a separate layer. And if you have business logic, that should also be separate. So instead of, because of course you could create a massive piece of code that does everything. It creates the UI, it reads the data, and it does some of the wrangling and, produces a report. But that's going to be very hard code base to navigate. And separation of concerns is also meant to help with the readability and understandability of a system, but also maintainability. Because if you work on a system where things have a very specific role, it will also be much easier to decide where a new feature goes. Or when a bug is happening, you will probably be much faster at figuring out which part of the system is affected. And Kedro introduces this through a couple of features. The first is the way we handle configuration. And configuration in Kedro is really, we think about it as the settings for your machine learning codes. And it's a way to define essentially your requirements for your data, for the logging of your pipeline, and for your parameters, and also allowing you to separate it in different environments, because many times the data you use for experimentation is not your real data. You might have some local data to play with, but then eventually you want to connect to a database. Configuration also helps you keep your credentials separate, so that if you need to connect to data sources, they're dealt with in a part outside of your business code in a way, so it's not embedded into the code where you are training your model. And what this helps with is really to make it very smooth to go from an experimental setup to production, because instead of having to dig through your code and update every moment you've referenced a local data set, to having to change to the database, there would be one central place where you swap it and you just keep it separate. That also means that if I need to run code that a teammate has written, I don't have to go through every place where they have hard-coded their local computer path and change it with mine. I can just go to one centralized file and say, okay, instead of my teammate, I want to reference my own local data. And the second thing that in Kedro really takes into this separation of concern is our data catalog. And the data catalog manages the loading and saving of your data. And it's available both as a Python code API and a YAML API. It's very connected to configuration, which I'll show you in a minute. And this really helps you, you never have to write a single line of code anymore that does anything with reading or writing a file. There's no code necessary for connecting to a database or providing your credentials to a storage system. And this makes it very easy and possible actually to write generalizable and reusable analytics code, because instead of having hard-coded logic around where your data comes from, Kedro abstracts that into a completely separate component, which means that your pipeline can be something you reuse. And what we've seen, especially with Kedro teams, is that sometimes people working in a specific industry, they have very similar pipelines. It's just the data might be different. But if you, for example, work in insurance, the data you're dealing with has a very similar pattern. It's just that maybe a specific data set needs some special treatment, but the general steps about where it comes from, how you pre-process, are really similar. So it's really great that you can have this catalog which you just swap in and out. And the way that Kedro kind of deals with your data sets is connecting it through the nodes and the pipelines using this catalog. So this is the first part of our pipeline again, where we have our raw input data, our company shuttles and reviews, and where we eventually create a model input table. Now, when we use a Kedro catalog, we can reference all these data sets in a YAML file. And Kedro will basically deal with the loading and saving of it. The only thing that we have to do is specify the type, the file path, and potentially if you want to version it, or sometimes more complicated data has more arguments. So if you're dealing with polars or TensorFlow, might be a little bit more information necessary to load it properly. But then Kedro can map these definitions inside of your pipeline, and this is why we had to do these string things, because Kedro knows how to match these things to data sets. And if I just go back quickly to my pipeline execution, some of you might have spotted this mention to a memory data set. And if we don't mention anything in our catalog, Kedro will deal with data as a memory dataset, which means in memory. Otherwise, it will try and find the more specified dataset type inside of the catalog. So that's what we'll be doing, exactly that right now. And I have also pre-populated a little bit of the catalog for you. So if you go to conf and then in base, you'll find this file, catalog.yaml, and I've already added the first entry for our company's datasets. As you might remember, we were using pandas for this, so it is a pandas CSV dataset, and the file path is data raw companies, so you can double check data raw companies. So let's add the other datasets as well, and let me just move this so we can check with the nodes. So we had shuttles and reviews. So let's add these in as well. Shuttles. And mind you, shuttles is actually an Excel file. So instead of using pandas CSV dataset, we can do pandas Excel dataset instead. And then we'll mention the file path, which is data raw shuttles. Yeah, and then finally reviews, which is a CSV dataset again. And I'm going to be a bit lazy and just copy that. All right, so this is step one of using this catalog. But at the moment, we still have this specific node that loads the data. And now we can just get rid of it. So we can just delete this. And we can also delete it from our pipeline. And now, before I execute, I'll pause for a moment. Because you might be wondering, okay, you just deleted the node that loads my data. So what happens now? So when Kedro starts executing this pipeline, the first thing it does, it will determine, okay, for this node, I need companies as input, and I'm going to need to produce preprocessed companies. So the first thing Kedro does is try and match these things to the catalog and see if it can find the definition. In this case, companies, it can find, and it can find it here. And it knows, okay, it's a pandas CSV data set. So in the background, it uses its own knowledge about data sets, which are called Kedro data sets, to load this data as a CSV data set inside of pandas and create that pandas data frame that we can do something with. And it is exactly the same for these other things. So if
Sorry, how does it find the catalog? Like, do you need to specify where the catalog is?
No, so this is a little bit of Kedro magic. The catalog is part of what we see as configuration. So it's inside conf base, or you could also put it in another environment. But by default, Kedro will always assume there is a configuration folder with a catalog in there.
Which it will be by default if you're creating, if you're using the Kedro pipeline create.
Yes.
Yeah.
Yeah. Or if you manually construct it. But what happens with the framework behind the scenes, and this is where we get in advanced Kedro territory, but when you execute a pipeline, it will also set up some components that Kedro needs to run that pipeline. One of these things, it will basically set up configuration loading, and this config loader component knows where these things are. So in the framework, we've embedded some defaults for default location for your catalog. If you've explored a little bit, you might have seen the parameters as well. That's another default configuration setting. Credentials is another thing that if you embed that in here, it will be read by default. And so when you do Kedro run, you specify the pipeline, in the background, it will do some logic to make sure it can load all these things properly. So when I obviously made a mistake here. That's always great. Let me see what I might have done wrong. I have my... I think I might have messed up my imports there. Okay, yes. So now it's running, but instead of having 4 tasks, obviously we only have 3. But you also observe that now we're loading data from companies' CSV dataset. So it's not a memory dataset anymore. Same for Shuttle's Excel dataset and Review's CSV dataset. So now it's using this catalog for you. So the beauty is that your data sets, they're all in the same location. So you don't have to dig through your code anymore trying to find these definitions. But also you don't have to write a single line that actually loads this data because Kedro has figured that out for you. Okay, I know we're almost out of time, but I do want to kind of finish this pipeline to show you the full Kedro magic, to say so, which involves creating parameters. And I have already pre-populated the parameters. And if you have a look at parameters data science, you will see there's already a little bit of stuff in there. And if I just quickly switch to my data science pipeline, this is where I'm now going to show you how parameters will be used. So you might have noticed when we were creating this split data methods, we were adding quite a lot of different hard-coded things. One of them was features. So I didn't spend a lot of time talking about it when I was creating the notebook, but I had this hard-coded list of features inside of this node. And with a code base this small, it's fine. But obviously, if you have a huge code base and you have lists of features spread around, you'll end up making a mistake at some point. And especially if you need to maybe get rid of this feature or add one, and you might have defined the same feature list in 3 places, you'll forget or your colleague forgets. So in Kedro, we also try to abstract anything that's essentially settings for your model inside of parameters. And this is just like a catalog. It's a YAML file, so quite a human readable format of data. And if we just quickly open that again, no. You can embed things like list, but also other values. So let me just clean up these screens. Okay, now I want to split this and get my data science pipeline there again. All right, so one of the things that we had in here, we had this feature list, we have a test size and a random state. And these things, in Kedro, we consider them all to be parameters. So instead of passing them in as just these separate components, we want to refer to them by using this parameters file. So before I can actually do that, because you might have noticed when I did a Kedro run, it complained about this test size and random states not, or in fact, features, random state and test size not being in the catalog. So it doesn't know how to find these things. So we need to define them here properly. So I'll just do test size, random states. And then we had some hard-coded values. So if we just double check, 0.2 for the test size and 3 for the random states. Okay, perfect. And now I'm going to delete this. And then some other Kedro magic, we can now just refer to them as parameters. The only other thing we need to do is, of course, in our pipeline, we haven't really talked about parameters yet. So what we'll do in parameters in the pipeline, we refer to this as params. And we need to refer to the section in parameters.yaml that we need. And in this case, this is model options. Okay. And then let me just double check. I'm going to need to parameters of features. That should be correct. And then similar to this one. I wish I had more time to fully explain all of this to you, but I do want to just show you a little bit of Kedro power there. And now let me try run the full pipeline. Let's see if I did that. Okay, it leads us executing more tasks. Okay, now we have a full running pipeline. And the second part is essentially where we're now loading our model input table. We're loading our model options from parameters. We're creating, saving training and test data. We have a regressor model, and then in the end, it actually puts out or prints out the result of our regressor. I know this was a lot. Again, I apologize for not explaining everything, but I do hope you have a bit of an impression of the types of features that Kedro has. So I'll stop here and I'll open the floor for questions. And in the meantime, I will also share some resources for you to continue from this moment onwards, basically. So let me, where do I stop sharing? Oh, there, stop sharing. All right. Okay, I can see some question. Is the load data function example of the nodes? Oh yeah, no, we dealt with that one. That was the Databricks one.
Also, Merel, I think this is already a success. Usually when we plan events that go past 8 p.m., you have everyone leaving at 8. But I think almost everyone stayed. So I think
brilliant. Oh, so happy to hear that. Well, let me share more resources to you. So first of all, again, the repo that I used, I will keep this open so you can clone it, play with it. It's essentially the workshop repo, so it's not the finished project. However, if you go to the Kedro docs, we have a very similar example where in the documentation we explain how you can go from this notebook embedding Kedro components. This documentation also explains a little bit more the behind the scenes of the config loader in the data catalog. So more time for you to play around with it. In general, I can suggest going to the Kedro tutorial if you want to get a deeper insight into Kedro ways of working. And this tutorial also uses this spaceflight example that I used, so it will be a bit more familiar. What else can I send you? We also have a blog. We also have a YouTube channel. But I'll stop talking there, and I'll take any questions that you all have.
We'll just read out a comment in the chat that I'm saying. First of all, a few people are saying thanks so much. They really enjoyed it. Yeah, Robbie's saying really appreciated this. Scripting and coding are both new territory for me. I grasp the idea of them, but it's not something I've personally done. So it's definitely a bit over my head. But from what I see and understand, Kedro would definitely be helpful when I try my hand at my own labs when I get there and play around with this at my own pace. So yeah, I think if you feel like leaving the repo open and everything, I think that would be great. Yeah, Alan's also saying super cool. Thank you. I'm wondering, yeah, what if somebody's used to just working in notebooks all the time, and if they're going to, you know, make one change or start kind of just working with Kedro, what do you recommend?
Yes, so this is one of the hardest things about Kedro and our, like, the way we've developed it. When we started building this framework, it's built by software engineers, by the way, and we all have very strong feelings about notebooks not being the right way to go if you want to build like proper high quality codes. However, notebooks are so great when you're experimenting. So my advice would be, if you do feel like Kedro could be helpful, but this full-fledged thing I showed you is way over your head, you're not used to IDEs, don't be afraid. Kedro is also a Python library. So you can use, for example, the data catalog is one of the most used components by itself. So it's used as a pure Python class that people just consume inside of their notebooks without the rest of the framework. So what a lot of people do, and especially teams where there's a mixed level of software understanding or like familiarity with IDEs, they will introduce components step by step. So people start exploring things like, yeah, the data catalog to get rid of all that loading of pandas data frames. And then eventually go to the full setup of having nodes and pipelines. One thing I think that really helps is we have, let me share you that link as well. We have a lot of, what are they called? Jupyter, I forgot what they're called now, but they're essentially like shortcuts where you can say load Kedro and it will load some of your setup for you. And one of the greatest things I think that we also have is this thing where you can do a load node and it will load your Kedro node inside of your notebook directly, so you can play around with it and run just that part of your code, so you don't need to execute the pipeline over and over again. Let me just find you this link. And then, as I also mentioned, if you are familiar with VS Code, we now also have a VS Code plugin, which makes it really easy to use like Kedro in an interactive way, because you can like navigate through the code. You have that Kedro Viz embedded inside, so while you're building your pipeline, you can see it update, and it really, yeah, I think it's a game changer. But I love PyCharm, so I'm not switched yet, but I've heard so many good stories from our users who really appreciate how easy it is to then work with it. I think I found it, Kedro and notebooks. There we go. Oh, I see a question here as well. Just curious, is Kedro limited to ML only? No, I would say Kedro is most useful when you're working with a data-centric flow. So you don't need advanced models or, you know, like really fancy stuff, but anything where it makes sense to set up your code in a pipeline way. So you're consuming data, you're dealing, like you're processing it, and then you're saving it somewhere. I think that's where Kedro makes sense. And obviously, if you're using Python, because it is a Python framework.
And then one last question. I think last time you had a statistic on how much more efficient it made people. There's something, I don't remember that.
It depends. Okay, it depends on the client.
Of course, it depends. But I think, do you have a story of kind of has this made people more efficient?
Yeah. So I think what the most powerful I feel like Kedro is when people are using it on a large scale in an organization. It does have a little bit of a learning curve, like I won't lie. I think especially for people who are not software engineers, this is a lot, right? Because we also assume you work with Git, IDEs are encouraged, etc. So there's a lot of steps to learn. But then once you're over that, that's when organizations really start to find benefits from Kedro, because it embeds a certain structure to every project. So like the location where your data sets are, where your parameters are, the way that you basically already have to think about your projects in this pipeline-centric way. So you divide up your code base like that. So getting started and working together is much easier with Kedro. One of my favorite stories, though, is for a team that they worked for a client. So they had a project where they had to build a machine learning pipeline for someone else. And the day of the delivery, the client was like, oh yeah, but what about, actually, we've just updated our data source. So the data doesn't come from SQL anymore. It now comes from, I don't even know anymore what it was, but like a different style of database. And this team was like, okay, that's fine. That's just the one change. The only thing they had to do is update that catalog. And instead of consuming the SQL data set, they had to change it to, I don't know, a NoSQL data set or something. And that was the only change they needed. And they came back to us saying, you're lifesavers, because if we hadn't used Kedro, this would have taken us at least 2 weeks to fix, because then we had all this specific logic. And now it was just a matter of a one line and a day of just tweaking a little bit.
I love it. Yeah, I think we're gonna have to leave it there for tonight. But yeah, thank you so much. It was really interesting to see that whole demo. So thanks for taking the time to do that.
No worries. And thanks for having me. And yeah, to all the people here, feel free to add me or Slack me in the women coding community, because I'm there on Slack as well.
Yeah, and likewise, if you want to reach out to me on Slack, very happy to. If you want to volunteer, give a talk, yeah, happy to chat. Have a great evening, everyone.
Great evening.
Bye, thank you.